Hey everyone, sorry I'm not there with you today, but as usual, we'll continue on with class through a video lesson I prepared for you this morning. Um, Hopefully you can see me today. Last time I prepared one of these, for some reason it didn't capture me along with the paper, but I changed the setting. I won't be able to tell until after I'm done recording this and look at it, so we'll see. At this point, you should have your equations notes out. They look like this on the front page. Remember, we wrote equations notes on the bottom. The only people that shouldn't have this are the people who are absent on Thursday or Friday. If you're one of those folks, hopefully you already grabbed this from the front counter up by where I keep the pencils. If not, go and get yourself a copy now. And everybody should have their Chromebook hopefully logged into Desmos already, but you shouldn't have started the activity called balancing moves yet. I mean, if you logged into it, that's fine, but hopefully you didn't get going on it yet. Let's save that until after the notes. So everybody should have their Chromebooks facing front, and we're just focused on these notes for right now. Um, let's turn the notes page to the notes we're going to do today, which is lesson four. But before we jump into that, let me say a few things. You do have homework due tomorrow. It's the verifying solutions to equations notes, or practice problems, I mean. Remember, those have to be written a certain way. You shouldn't be solving them. You should be substituting the value in for the variable and working the math out to see if the numbers come out balanced at the end. If you don't know what I'm talking about because you were absent, watch the video with it so you see exactly how those are supposed to be written. Um, a lot of people have been wanting to come retake the algebraic expressions quiz, and I wasn't available last week for various reasons, and so I want to invite everybody to come retake it tomorrow after school. I do plan on being there tomorrow, hopefully. And so tomorrow after school, I'll review the topics for people. If you show up at like 2:51, we can go through the quiz like as a class. I'm expecting quite a few people to show up. I can answer your questions. We can do some practice problems until maybe about 3:20, 3:30, and then I'll let everybody retake the quiz. Hopefully you're done by around 4. And the more people that come in this one time, the better it is for me rather than having to do a lot of different retake sessions. So that'd be great if you wanted to show up. All right, so now let's look at the notes for today, the lesson four notes. Really, we're going to wrap up this idea of looking at algebraic equation stuff as a tape diagram and then relating that to an equation and solving the equation, and also review what it means to be a solution to an equation. Remember, we read that definition to ourselves like a million times on Thursday and Friday. Also, again, I apologize. This document camera that I have at home, it always wants to go out of focus and in focus. I know it's annoying. It's all I have here at home. Um, okay, so it says DeAndre bought a juice for $3 and two sandwiches that cost X dollars each. Together, the items cost $11.50. Okay, and so let's make a tape diagram. In our tape diagram, we're going to need, I should have made that a little bit lower. Oh, well, whatever. We're going to need three boxes. Um, one box is going to represent $3 for the juice, so I'll put a 3 in it. And then the other two boxes are going to represent the unknown sandwich cost. And so it says X will represent the sandwich cost. And so we'll put an X here and an X here. And then since the whole thing cost 11.50, um, across the top, you make a little thing that kind of represents the length and label it as 11.50. And there you go. There's your tape diagram. And so an equation that would go with this would basically just be these things in the boxes added up equals the length of the whole thing that we put across the top. So we could write 3 plus 2x. I personally think that the constant term should always be on the right side. And so I'm going to write 2x plus 3 equals 1150. And now we need to solve it, which means to find its solutions, and then we'll write the meaning of the solution. But like I said on Thursday/Friday, anytime we're going to solve an equation in our notes, let's do it in this My Notes section because we have this nice tall space to work with. And so I'm just going to transfer this equation to over here. But before we do that, we always define our variable. I know it's already written in the words here, but it's still our job to put it up there. And so we're going to write X is cost of a sandwich. And then we'll put the equation underneath. So 2x plus 3 equals 1150. And then we have this plus 3 and we have a times 2. And so in order to solve, we will need to subtract that 3 and divide by 2. This will be a two-step equation. And so we're subtracting 3 from both sides of the equation. So I'm writing minus 3 underneath the plus 3, minus 3 underneath the 1150. These two make a 0, leaving us with 2x equals 850. And make sure to keep those equal signs in a nice straight line for me, please. And then let's divide both sides by 2. And we will get x equals $4.25. And so our solution is $4.25, or x equals 425. Remember, the solution to an equation means a number that, when substituted into the equation, makes the equation true. And so when you get to the end of an equation and it looks like this, what you're saying is, if you were to take this 450, sorry, 425, and put it in for x here, it should balance this equation or make it true. And so a little bit of mental math real quick. 2 times 425 is 850, right? That's why we have 850 here. And then when you add the 3, you get 1150. That's a check. That's a verify, like you're doing in your homework. And so, but that's not what we write here in the meaning of the solution. Our meaning of the solution will be each sandwich costs $4.25. Okay, and then down here in this second section of the notes, I want to make a little change. Do me a favor and change this 3 right here in the first equation to a 6. And then what I would hope you notice is that now this equation and this equation are exactly the same. If you were to do the distributive property on the second equation, you would get 2x plus 6. And so these are the exact same equation, except this one is in standard form. Going back to our old expression stuff, standard form and factored form. And we're going to talk about this more later this week and next week, but there's like two different strategies you can use to solve the exact same equation that's in standard form and in factored form. And I just want to show that to you real quick so you can see it once. Um, I'm going to just straight write underneath the equations because I can do that with my purple marker. You should be able to see it. But with pencil, that'd probably be hard to see through these words. And so for you guys, it might be better if you take this equation, the standard form, and write it over here. In fact, I'll just do the same thing. I'm already doing it, so I might as well do it, right? All right, so here's the standard form. This one's going to work the way we've been practicing it a lot. Let's subtract the 6 from both sides and get 2x equals 5.5. And then we'll divide both sides by 2. And we'll get x equals, I think that's 275, I hope. Yeah, pretty sure. 275. Okay, now that means this one should also be x equals 275. But look, there's a different procedure or a different order of things we could solve them in. Because we did this one in SAD-MEG order, right? I did my subtractions and my divisions. This one, I mean, we're still going to do it in SAD-MEG order, actually. It just looks a little different. Because what we have here is a multiplication. The 2 is multiplying by the things inside the group. And then something that's grouped. That's the G in SAD-MEG. We're supposed to save that for last. And so we actually divide this one first. I'm going to run a fraction bar underneath the whole thing. Not the whole equation, but like the full 2 quantity x plus 3. And I'm going to divide it by 2. And what that does is the two 2's make a 1. They go away. And I'm left with x plus 3 equals 5.75. If you have a calculator on your desk, or if you're really good at mental math, you could be checking me on this. And then now I'll subtract 3 from both sides, because now I'm working within what used to be grouped. I just didn't write the parentheses anymore. And again, I get x equals 275. And so I just wanted to show you the two different ways to solve the same equation that's just written in different forms. We'll practice that more later this week, like I said. Okay, and so your job for the rest of the period is to work on a Desmos called balancing moves. Um, the whole thing is about this idea of equations being balanced scales, which shouldn't be anything new to you. We've talked about that a little bit recently, and you did Desmos activities in sixth grade where you look at equations like balanced scales. In today's activity, you don't have to like really work any equations or write equations or solve them in that way. I want you to just practice solving the scales, figuring out what the weights equal. Tomorrow we will do like the continuation of this Desmos. It's almost the exact same thing, but tomorrow we'll be writing equations and solving them that way. So a little bit more rigorous tomorrow, we might say. I want you to stay in your seats near your group mates. You can definitely work together. I encourage you to. That's the whole reason we sit in groups. Talk to each other, help each other out, ask each other for help if you need to. Um, then, if you finish early, there's a few things you can do. Um, you can do the challenge Desmoses. I have been assigning some more of those. Remember, you can join the challenge Desmos class by entering the code that's on the challenge bin on the wall over there by where the calculators, scissors, markers, that sort of stuff is. Also, in that same bin are a couple of new papers, and they're two of my favorite challenge things that I offer students the whole year. And so I'll definitely give you extra credit and maybe put these up on the wall if you do a really good job of them. One of them is a really famous math problem called the pool border problem, where we don't know how big the pool is, so we call it S, although I hate S. We could change it to X if you wanted to. And can you write an algebraic expression that says how big the pool border is in three different ways? It's a good one. And then this one here, the challenge is you're working somewhere where they mix paint, and you have to mix red and blue paint to make purple paint. And the only information you get really is how much purple paint the person wants. And you have to figure out the right amount of red and blue. If you read the front of this paper really carefully, I go through an example of how to solve the first row here if they want 9 1/4 pints of purple. And then there's a backside to this paper where I'm asking you to follow the exact same steps that you saw in the example. And that should solve the, the second row. And then there's a blank paper stapled to it. And I want you to use that blank paper showing the exact same algebra you have to show your work. This whole thing's about showing your work. If you don't show your work, it's almost like nothing. Show your work to figure out the last two rows. And if you show that work really great, I'll definitely give you some extra credit and put it up on the wall. Um, and then also, I suppose if you haven't done your homework, you could finish that in this class as well. Let's look at the Desmos just real quick together, and then you just work on it for the rest of the period. Let's see here. Here it is. So the first screen, you just mess around with the scale to see what it does. In this one here, the idea basically is that these two sides of the scale have to be the same, right? It's balanced. And so this right side has four twos. So if you take those four twos away and take four twos away from the the left side, the side with with all twos, then you should be able to kind of figure out how much the green squares weigh is sort of the idea of the whole thing. Um, they talk about two different strategies in this activity a lot, which is supposed to be like the two different ways I just showed you how to solve equations in your notes. I guess one thing that could be kind of confusing for some folks that I just want to show you, and then I'll let you work, is on screen 6, what they mean by boxing all these things and then crossing them out is that like they're taking all of that off the balance scale. They're gonna take the purple circle and this green square on the left side off, and they're gonna take those three 20 squares off the right side. Like, and so they want you to imagine all those things being gone as like a step in solving the equation. All right, that's it. Try to finish this Desmos before the end of the period and do some challenge or some homework if you finish early. See you guys.